Understanding trigonometric ratios is extremely important. Many entrance examinations test you on your basic knowledge of sine, cos, tan, and those pesky things. So here's a quick tutorial on what exactly are meant by the six trigonometric ratios and how do we remember the values of the ratios for specific angles. First things first, what exactly is a trigonometric ratio? Well, it all starts with a right angled triangle. Supposing I have a right angled triangle, let's name this A, B and C. So angle B is my 90-degree angle. I can assume angle ACB to be my reference theta. So when I say this is my reference theta, for the angle theta, AB is considered to be the opposite side and BC is considered the adjacent side. AC, the side opposite to the right angle, is always considered the hypotenuse. The definition of the hypotenuse is in a right angle triangle, the side which is opposite to the 90-degree angle is called the hypotenuse. And as a rule, it is the longest side in the right angle triangle. Now, we all know the famous Pythagorean triplet, where if one of the sides is 3 and the other side is equal to 4 units, then the hypotenuse is 5. And why? Because 3 square plus 4 square is 5 square. AB square plus BC square is AC square, and because 3 square plus 4 square is 5 square, the length of the three sides can be 3, 4 and 5, with 5 being the largest side, which is the hypotenuse in this case. Now if you take a look at all the three sides, you can take any two sides and the two numbers will form a ratio, correct? For example, I can say in this particular triangle ABC, the ratio of the sides AB and BC is 3 is to 4, or BC is to AC is 4 is to 5, and so on. So in trigonometry, we give specific names to all these ratios. So let's take a look at what each of these ratios are. So again, let us say my right angled triangle ABC, angle theta, this is my opposite side, this is my adjacent side, and this is my hypotenuse. Then sine of theta is the opposite side upon the hypotenuse. So if theta is the angle and theta will have a particular value, it could be in degrees, it could be in radians. So the value of sine of theta is nothing but the value of the ratio of the length of the opposite side to the length of the hypotenuse. Similarly, cos of theta is defined as the ratio of the adjacent side to the hypotenuse, and tan of theta is the ratio of the opposite side to the adjacent side. So if I take a look at the three things carefully, I can quickly identify that when I take sine theta divided by cos theta, that is opposite upon hypotenuse divided by adjacent upon hypotenuse, the ratio opposite upon adjacent is nothing but tan theta. So from this we also get that the ratio of sine theta and cos theta is nothing but tan theta, correct? So I have my three basic ratios. The ratio of the length of the opposite side to the hypotenuse is sine. The ratio of the adjacent side to the hypotenuse is cos. And the ratio of the length of the opposite side to the adjacent is known as tan. Now, instead of opposite and hypotenuse in that order, I could have taken hypotenuse and opposite, right? So we get three more ratios. So if I say sine theta is opposite upon hypotenuse, then 1 upon sine theta, which is the hypotenuse upon the opposite, is defined as cosec theta. So 1 upon sine theta is cosec theta. Similarly, if cos theta is adjacent upon hypotenuse, then 1 upon cos theta is the hypotenuse upon the adjacent, which is called sec theta. And if tan theta is defined as opposite upon adjacent, then 1 upon tan theta is adjacent upon opposite, and that is called cot theta. So now we have seen the 6 ratios. The ratio of the opposite side and the hypotenuse is sine, the adjacent side and the hypotenuse is cos, and the opposite and the adjacent is tan. Similarly, the ratios of the hypotenuse to the opposite is cosec, the hypotenuse to the adjacent is sec, and the adjacent to the opposite is cot. Now, this quickly can help us understand that if I know the values of sine, I can easily calculate the values of cosec because they are reciprocals, 1 upon of each other. Similarly, if I know the values of cos, I can easily calculate sec because sec is nothing but the inverse of cos. Similarly, if I know the value of tan, then 1 upon tan will directly give me the value of cot. Also remember, we saw sine upon cos is tan. So I don't even have to remember the values of tan. If I know sine and cos, then I can easily calculate the value of tan and the remaining 3 trigonometric ratios. So now the task is how to remember the values of all these trigonometric ratios. Well, let's understand how we can use a trick to create this table, right? So what we are going to do is we are going to have specific values for which we are going to understand how to put in the values of sine, cos, tan, cosec, sec, and cot. Now remember, the specific values of sine, cos, and tan which we are going to take a look at are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. What does it mean? Nothing. If in the right angled triangle, if this is theta, right, then when the angle is 0 degrees, what is the value of the ratios? That is the sides. Similarly, if theta is 30, then what will be the ratios? 45, 60, 90, and so on. Now, the hack to remember this is pretty simple. Let's start with the first, sine of 0, right? So I will start with 0, write 1, 2, 3, and 4. I divide each value by 4. And my last step is taking the square root of each value. So root of 0 by 4, then root of 1 by 4, then root of 2 by 4, root of 3 by 4, and root of 4 by 4. These are the values of sine. So let's simplify. 0 by anything is 0, square root is 0. Root of 1 by 4, 1 by 2. This is 1 upon root 2. This is root 3 upon 2. And this is equal to 1. Once you are able to fit in the values of the 5 angles for sine, the entire table can now be simply filled up by remembering few facts. Remember, the values of sine, they go from left to right. For cos, the exact same values go from right to left. So, for 0, the corresponding value is 90. For 30, 60, and 45 is itself. So now I can write 0, 1 upon 2, 1 upon root 2, root 3 upon 2, and 1. 2 values done. Now, tan was nothing but sine divided by cos. So I just take the ratios. So 0 upon 1, 0. 1 by 2 upon root 3 by 2 is 1 by root 3. 1 by root 2 upon 1 by root 2 is 1. Root 3 by 2 upon 1 by 2 is root 3. And 1 by 0 is undefined. So tan 90, undefined. We don't know what it will be. Now, the remaining are also simple because cosec is nothing but 1 upon sine. So 1 upon 0 unknown, 1 by 2 is 2 by 1, 1 by root 2 is root 2 by 1, root 3 by 2 is 2 by root 3, and 1 upon 1 is 1. Similarly, for sec, just as sine and cos were left to right, right to left, cosec and sec can also be written the same way. So 1, 2 by root 3, root 2, 2, and undefined. And finally, if tan is sine by cos, then cos is either cos by sine or simply 1 upon tan. So reciprocal of tan values, 1 upon 0 unknown, 1 by root 3, 1, 1, root 3 is 1 by root 3, and for unknown the reciprocal is 0. So as you can see, once we know how to write the values of 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees for sine, we can easily fill in the values for all the remaining tables. So remember, remembering all these 30 values is actually pretty easy. Once you remember sine left to right, write the entire thing right to left for cos. Sine upon cos gives you tan. 1 upon sine gives you cosec. 1 upon cos gives you sec. 1 upon tan gives you cot. And that's how the entire table of trigonometric ratios can be remembered. If you like this video, then do hit that like button, share and subscribe. And do put a comment on which other topic of maths you would like to see me make a video on. Till then, wish you all the best.